Multi-server waiting line model. The equation for probability of 0 customers in the system. In multi-server waiting line models, it is important to know the probability that there are no customers in the system. This represents the percentage of time the system is idle. Also, the probability of 0 customers being in the system is used to find the probability of n customers in the system, the probability of an arriving customer waiting to be served, and also the average number of customers in the system. In this equation, we have 1 as the numerator, and in the denominator, we have a series of expressions that are added together. In the denominator, we have a sigma notation. The sigma notation tells us we're going to sum up the following expression up to n. How do we know what value of n to start and finish with? Well, let's start off with a couple of more variables. We'll start off with s, and s stands for the number of servers, or represents the number of servers. N is the specific server number. So if we had 5 servers, n could be any number between 0 and 5. So we can see in our sigma notation that we are going to start with n of 0. So we're going to start with the 0 server. This is represented by the lower value n equals 0. This tells us that we're going to start with server 0 in this equation. The upper value above sigma tells us we're going to run our expression up to n equals s minus 1. So again, if we have 5 servers, we're going to go up to server 4. After the sigma notation, you can see the expression in the green box. We're going to sum up the values for this expression with n equals 0 through n. Let's work with this expression if s equals 4. First, we need to determine how far out we're going to take this expression. We're going to take this expression out to n equals 4 minus 1, or 3. So again, we're going to start at server 0, and we're going to end at server 3. Let's work through our notation and expression, knowing that we're going to start at server 0 and go to server 3. So let's start off with server 0. So what we're going to do is we're going to plug in 0 where we have the variable n. So here we have 1 over 0 factorial times lambda, which is our arrival rate, divided by mu raised to the 0 power. And using certain mathematical rules pertaining to 0 factorial and raising a value or a number to the 0 power, we know that 0 factorial is 1. So 1 over 1, or 1 divided by 1, is 1. And any number raised to the power of 0 is 1. So we will always have 1 at the beginning of this expression. So next we're going to add in. Remember, sigma is, we're summing up. And we're going to plug in 1 for the variable n. So we're going to have 1 over 1, which is 1 factorial. 1 times 1 is 1, times our arrival rate, lambda, divided by our server rate, mu, raised to the first power. We're going to do server 2. Server 2 the expression for server 2 is 1 over 1 times 2, which is going to give us 2, times lambda over mu raised to the second power. And then we're going to end with server 3. We're going to have 1 over 1 times 2 times 3, which is going to give us 6, times lambda over mu raised to the third power. So this is how we apply our sigma notation to the expression that is inside the brackets for the equation of probability of 0 customers in the system. Next, we're going to move to the right side of the plus sign. Here, we're not going to use any values of n, but we are going to use the values of s, the number of servers. And this is going to be the total number of servers. So in this case, it's going to be s equals 4. So s factorial is 1 times 2 times 3 times 4, which is going to give us 24. So we're going to have 1 over 24. Let's move to our next factor on the right side of the equation in the denominator. We have lambda over mu raised to the s power. Okay, again, s equals 4. We're talking about the total number of servers on this side. So we have lambda over mu raised to the 4th power. At the end of the expression, we're going to have the number of servers times mu divided by s times mu minus lambda, or s times the server rate divided by the number of servers times the service rate minus the arrival rate. So let's apply our s equals 4 here. We're going to have 4 times mu divided by 4 times mu minus lambda. And that's the basics of the equation to calculate the probability of 0 customers in a system in a multi-server waiting line model.